Okay, we want the frequency response of this circuit. The input is this current source, U of t. The output is the current through the inductor, I of t. Since we want a frequency response, we're looking at a steady state sinusoidal problem in which omega is an independent variable. So let's convert this circuit to the frequency domain. So our impedance of the 2 ohm resistor is still 2 ohms. The source becomes a phasor which can be a function of frequency, 3 ohm resistor, and a inductor which has an impedance of J times omega times 3 henries in ohms. And our current I becomes a phasor function of omega. Now if we combine these impedances, we have 2 circuit elements that are in parallel. We know the current into the combination. We can use a current divider. So the current I of J omega is equal to the input current, U of J omega, times this other impedance, 2 ohms, over the sum of this impedance and this total impedance, so 2 ohms plus. These 2 elements are in series, so the equivalent impedance over here is going to be 3 plus J3 omega ohms. The frequency response, H of J omega, is the ratio of the output, which is I of J omega, as a phasor to the input, U of J omega. So dividing both sides by U, this becomes 2 over 2 plus 3 is 5 plus J3 omega. And there is our answer.